The first presentation from Tim Smith will be on the process for evaluating reasonably available control technology and reasonably available control measures, also known as RACT and RACM.
I would like to talk about the RACM and RACT requirements of the PM implementation rule. Of course, RACM stands for reasonably available control measures. RACT stands for reasonably available control technology. RACT is essentially a subset of RACM. I'm going to talk about the approaches to these regulatory requirements in the recent PM implementation rule, and I'm going to talk about what that rule requires in terms of steps for identifying RACM and RACT. RACM and RACT is required by the Clean Air Act, it's required by our regulations, and it's explained by a recent Federal Register notice. These provisions are in Section 172C1 of the Clean Air Act as part of the overall requirements for state implementation plans. EPA's Code of Federal Regulations includes these requirements at 40 CFR 51.1010. And there's a fairly lengthy discussion of explaining these requirements in the Federal Register preamble. On April 25th, 2007, as Rich mentioned, we finalized the PM implementation rule. And in the preamble section 2F, which is on pages 20609 through 20633, explains in detail these requirements. The regulatory language is in two parts, 51.1010A and B. 51.1010A, which largely parrots language in the Clean Air Act, says that the state implementation must include a demonstration that the state has adopted all RACM, including RACT, necessary to demonstrate attainment as expeditiously as practicable to meet any RFP requirements. The state implementation plan has to include a list of measures that the state considered and has to have information sufficient to support that the state has adopted all measures. And in 51.1010B, the regulatory language clarifies that in determining RACM, it's a cumulative analysis. In other words, in determining the technically and economically feasible measures that are necessary as RACM, it's necessary to look at those measures as a whole and not individually. And if cumulatively the total effect of all the measures would advance attainment by 1 year, then those measures have to be selected as RACM. The overall approach to RACM and RACT in the final rule is discussed in Preamble Section 2F2. This discussion in the preamble to the rule discusses the options we considered in the final rule and discusses how the RACT and RACM approach for PM 2.5 differs from other pollutants such as ozone. Under the PM 2.5 implementation rule, RACT is not an independent requirement. Under the ozone program, sources above a certain emissions threshold have to have a RACT analysis irregardless of the nature of the attainment, non-attainment problem and the severity of the pollutant levels. Under the approach in the final rule for PM 2.5, states have the flexibility to tailor solutions to the unique problems of their given non-attainment area. States have to conduct an analysis to show that all RACT and RACM have been adopted and that those measures that have been adopted provide for expeditious attainment. The degree of documentation needed to make such a demonstration will vary depending on the attainment date, as has been discussed by Rich in a previous presentation. So what are the steps to determining RACM and RACT? Steps are as follows. First, to identify the technically and economically feasible measures and their associated emission reductions. Secondly, to conduct air quality modeling and related analysis to assess the air quality impacts of those emission reductions. And finally, to make a selection of RACT and RACM. Technical feasibility is discussed in Preamble Section 2F4. In essence, what technical feasibility means is there a measure that works? Is there a measure that reduces emissions of PM 2.5 and its precursors? Considering factors such as process and operating conditions, raw materials, physical plant layout, what a measure's impacts would be on other environmental parameters such as water quality, and the energy impacts of the control measure. Although not explicitly discussed in the preamble, it's also useful to note that a measure's technical feasibility also needs to assess how long it would take to implement such a measure. Economic feasibility is discussed in Preamble Section 2F5, and what economic feasibility means is the cost of a potential measure reasonable for a regulated entity to bear? Now, once you've identified a technically feasible measure that works in reducing emissions, what impact does that have economically on a regulated entity? Economic feasibility considers costs, the cost in terms of annualized dollars per ton of emissions reduced, and the economic effects on that plant and the local economy. While the cost per ton for previous measures can often provide an indicator of reasonableness, the ability to absorb that cost may differ across source categories and industries. So it's important that the dollars per ton from previous measures not be looked at as sort of an absolute as to whether a measure is economically feasible. For some measures, and this I think is particularly true for mobile source measures, the feasibility of a measure also depends on or can depend on the availability of public funding and resources. A few more points with respect to economic feasibility. First of all, the regulation does not contain a fixed dollar per ton cutoff for the level of cost that we believe are reasonable. Consistent with our overall approach, the rule allows state and local agencies the flexibility to determine the measures that are necessary in their area to provide for expeditious attainment. It is likely, however, that in looking across the various pollutants, direct PM 2.5, precursors such as SO2 and NOx, direct PM 2.5 has an immediate effect on ambient PM 2.5 levels. Precursors have to react in the atmosphere to form PM 2.5. As a result, a given reduction in tons of PM 2.5 direct will likely have a greater impact on ambient 2.5 levels per ton than per ton of SO2 or NOx. Accordingly, the reasonableness, the dollar per ton level for PM 2.5 is likely to be at a greater number than for SO2 and NOx. Finally, in determining costs, we mentioned that there's a number of references, including the EPA cost manual, but certainly many others. If a company contends that it cannot afford technology that appears to be racked and rackham for others, and a state wants to make a conclusion consistent with such a contention, thorough economic support is needed. For example, if it is asserted that there would be severe impacts on a local economy, such as a plant shutdown or severe contaminant, it needs to be supported with an economic analysis. And in the preamble, we discuss a number of parameters that should be included with that. Preamble Section 2F6 contains examples of candidate control measures that states should be considering in developing their PM 2.5 SIPs. I'll talk about these candidate control measures in much more detail in a later presentation. States are required to address any measures that are identified in public comments. EPA sees an important role for itself to promote information sharing, that is, to provide websites that indicate the types of measures that states are considering so that others will be aware of those measures. And a few additional points with regard to identifying measures. As mentioned, there is no tonnage threshold for RACT. While there is no tonnage threshold for RACT, it's important to note that it's likely that screening assessments can inform the choices of measures to evaluate. EPA is not saying that in each and every area, for example, that a state has to do a detailed engineering analysis of each and every source in its entire inventory. Such an approach would clearly be unreasonable. But in deciding which sources don't contribute to expeditious attainment, it's necessary to do a demonstration of that systematically identifies the sources that are believed not to contribute significantly, and to explain to us and to the public why that's the case. Certainly areas with a more severe problem will likely need to evaluate smaller sources, as mentioned previously. It's also important to note that it's necessary to evaluate sources throughout the entire non-attainment area for available controls. While certainly in a number of areas there are sources near the design value monitor that will certainly be a key part of the solution to those non-attainment problems, it's necessary to evaluate sources throughout the non-attainment area for possible controls. A guiding principle for the analysis is to show that in selecting RACT and RACM, you haven't excluded a group of reasonable controls, including controls on smaller sources than you applied measures to, that together could advance the attainment date. Although not explicitly part of the RACT and RACM analysis, it's important to note that the rule does require investigation of intrastate sources outside of the non-attainment area. In defining an attainment date, which is expeditiously as practical, there's a basic question: could transport of reasonably controllable intrastate sources, i.e. outside the non-attainment area, could those contribute to the advance of an attainment date? The next step, after identifying technically and economically feasible control measures, after identifying the emission reductions associated with those measures, the next step is to conduct air quality and related analysis to show that those measures have the air quality impact of providing for attainment as soon as possible. And in Rich's talk, he covered a number of items with respect to that and discusses different scenarios for this air quality and modeling analyses. So the endpoint of the analysis is decision on RACM, RACT, and intrastate measures and the attainment date. In summary, the RACT and RACM that are selected must include reasonable, technically and economically feasible measures if those are necessary for attainment as expeditiously as practicable. If collectively the measures would not advance the attainment date by a year, then those measures may be excluded. Preamble Section 2F7 discusses the relationship between EPA's Clean Air Interstate Rule and the RACT requirements of the Clean Air Act and of this rule. As you know, the Clean Air Interstate Rule will obtain substantial long-term reductions of PM 2.5 precursors, that is, reductions in SO2 and nitrogen oxides. The preamble discusses how we view the relationship between those reductions and the RACT requirement. For SO2, there's a presumption that in states fulfilling their care reductions entirely through electric generating unit reductions, that compliance with an approved air SIP would satisfy RACT. States may rely on this presumption without further analysis, but must respond to any public comments on whether that presumption is appropriate. A state may impose additional SO2 requirements on a specific plant if a state determines it's a reasonable means to attain the standards expeditiously. However, it's important to consider the potential disbenefits of taking such an action. For example, beyond care controls on a local source may lead to increases elsewhere, and so that effect would have to be taken into account in assessing the overall effect of doing that. For NOx, there's a presumption, again, in states that are subject to annual care reduction entirely through electric generating unit reductions, that compliance by EGUs would, with the approved care SIP or FIP, would satisfy RAC, provided that a source with existing selective catalytic reduction would operate year-round. Now, what do we mean by existing SCR? The rule defines existing SCRs as those that were put in place by November 1st of 2005. And for those existing SCRs, the NOx presumption is only available to states if there's an enforceable requirement for year-round operation for those existing SCRs. There is no presumption related to direct PM 2.5 emissions for electric generating units and RAC. The deadlines for submitting and implementing the RAC requirement are discussed in Preamble Section 2F8. Essentially, the RACM analysis has to be submitted with the SIP by April 2008. The measures have to be implemented such that they have an effect the year before the attainment date. That is, they have to be in place the beginning of the year before the selected attainment date. There's provisions discussed in the preamble for demonstrating that more time is needed for implementation consistent with an expeditious schedule. Section 2F9 of the preamble talks about, just reviews that the pollutants that have to be included in a RACT and RACM analysis, consistent with our overall policies described elsewhere in the preamble for precursors. The RACT and RACM analysis has to look at direct PM 2.5, has to look at SO2, and looks at other pollutants that are considered precursors consistent with those discussions. NOx, again, being presumptively in other words, presumptively would require a RACT and RACM analysis. VOC and ammonia presumptively would not require RACT and RACM analysis unless a state found, as part of the overall SIP, that they contributed significantly to the non-attainment problem. So what about sources that are subject to previous technology determinations, such as RACT under a previous SIP program, BACT or LAIR under major source, new source review programs, or MACT requirements under air toxics national regulations? For any prior determination, a state has to assure that RACT is met, and none of those previous technology determinations provide an automatic technology determination for a purpose of this rule. The state must assure that RACT is met, either through a new RACT determination or through a certification that a previously required RACT controls continue to represent RACT. In saying that, keep in mind that for the fine fraction of PM, that is PM 2.5, there really haven't been any RACT determinations in our judgment. For certain precursors, there likely have been previous RAC determinants that may be, in some limited cases, applicable. And to clarify, a new RAC determination is certainly required if a previous RAC determination concluded the RAC was not controlling the source at all or did not address the pollutant in question. Similarly, technology determinations under new source review programs such as BACT and LAIR findings do not automatically constitute RAC. While it's logical to presume that in a lot of cases a very recent technology that under these programs that applied very stringent controls may be tough to beat in terms of a RAC finding, it's not automatic. It's necessary to provide the reasoning of why such a prior determination would still represent RAC. Also, under the MACT program, which requires stringent VOC controls for a number of categories such as chemical plants, it may be unlikely that more stringent controls for RAC would be available, again, in those limited circumstances where VOC is a precursor under the PM-SIP. So it's likely that the determination would be fairly streamlined, but it's necessary to provide the reasoning and the logic and allow the public the chance to review what the rationale for a finding that previous controls still represented RAC. Many MAC standards also address PM 2.5 and as often as the way that they require compliance for heavy metals. And again, for these MAC standards which FPM limits, it's not automatic. There's issues with respect to the fine fraction. There's issues related to the degree of emissions capture that in particularly should be addressed in determining whether a MAC standard would represent RAC under a PM 2.5 SIP. And finally, for NOx, it's as a general point and as a general matter, it's useful to note that under the ozone program, certain measures may not be required year-round, and if they were required for ozone purposes, it's important for a PM 2.5 SIP to consider what would be the costs and effects of year-round, of extending those ozone season controls to year-round. So with that, that wraps up my points I wanted to make with respect to the RAC and RACM requirements in the PM 2.5 rule. My contact information is on the first slide, and please don't hesitate to call me with any questions or that you would have with respect to anything in this presentation.